All right, today's lesson is lesson 10.4 on series and sigma notation. Let's begin with what a series is. It's the sum of consecutive terms in a sequence. Okay, and what we're going to look at is letter A. So we have 1, 2, 3, 4 as a sequence, and we're going to add each term together. And so 1 plus 2 plus 3 plus 4 will give you 10. Okay. Letter B, we have 2 plus 4 plus 6 plus 8, and then keep on going to infinitely. So if we add all those together, we can say it's going to be infinity. Okay, so because you're going on and on forever. Letter C, we're adding 1/2, and then it looks like we're doing half of 1/2 is 1/4, half of 1/4 is 1/8, and we're going to keep on doing that and breaking it down forever and ever and ever and ever. And essentially, if you add all those fractions up together, you will get the number 1. Okay. If we look at partial sums, the notation is S sub n representing the number of terms, and it's the sum of a specific number of terms. Okay, so we're looking just for a specific number of terms. If we look at this example, we have the sequence of 3, 6, 9, 12, 15, and so forth, and it looks like we're going up by 3. So if we're looking for the partial sum S sub 2, we're looking at the first two terms. So 3 plus 6 will give me 9. Then if I'm doing S sub 5, I'm looking at the first 5 terms and I'm adding those up, which will give me 45. If I'm looking at S sub 7, I'm looking at the first 5 and 2 more. Okay, so we know the first 5 is 45, and then we have to add 3 to 15 to get term 6, which would be 18, and the next term would be 21, so we're going to have to add those to get S sub 7, which was going to be a total of 84. Okay. Now we have something we can use called sigma notation to rewrite these series, partial sums. And we use this notation again, S sub n for partial sum. And we can identify, let's start with the lower limit. Okay, oops. Okay, the lower limit is represented by this number here. It's your first term number. So we're going to start at term number 1 if it has a 1 there. And I have my upper limit, and it's the last term number. So let's say I wanted to go from 1 to 7 like in this case. So that would my 7 would go here. Then I have the rule for the sequence. Okay, we put the rule here, whatever it would be based on what the sequence is. And then we can also say this I, it could be I or some other letter, we call it our index. Okay, it's a way to identify our lower limit and just identify our lower limit essentially. Okay. All right, so let's look at example 2. Write in expanded form and find the sum. All right, so I'm going to notice that my sequence, the rule for it is k squared, and I have I equals 1, so my index is going to start at 1, my lower limit, and I'm going to go to term 5. So I can say I have 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. And I'm going to add all of these up, so I would have 1 plus 4 plus 9 plus 16 plus 25, and that will give me a sum of 55, and that is my answer. Okay, that is the sum of this sequence. Okay, let's go to the next page. Do a couple more examples. All right, example 3. I have m equals 1, that's the starting, right? That's my lower limit, and I'm going to go to term 6. So I'm going to be plugging in 1, 2, 3, 4, 5, and 6 into this rule of the sequence. So I can say S sub 6 equals, I'm going to substitute 1 in, so 100 minus 1 is 99. 100 minus 2 is 98. 100 minus 3 is 97. Oops. 100 minus 4 is 96. 100 minus 5 is 95, and 100 minus 6 is 94. And my sum is going to be 490. Okay, let's look at example 4. Again, my index, my lower limit is 1. I have my rule here and the term I'm going to go to, which is 6. So I'm going to substitute in 1 through 6. So I'll start with the first one. 1 times 1 plus 2. Then I'm going to substitute 2 in. 2 times 2 plus 2. Substitute in 3. 4. 5. Over, and 6. Okay, and I'm going to go ahead and write 3 plus 8 plus 15 plus 24 plus 35 plus 48 to give me S sub 6 as a sum of 133. Okay, that is when we have it in sigma notation and rewriting it as expanded form and finding the sum. Now we're going to use sigma notation to describe the series. So here I am, I'm given this series, and I need to write it in sigma notation. I can see that I'm doing 4 times 1 would give me 4. 4 times 2 would give me 8. 4 times 3 would give me 12. So we're kind of trying to figure out what the rule would be. So that's the important part, because we know that we're starting at 1, so n equals 1. We know we have 1, 2, 3, 4, 5 terms, so it goes to 5. And my rule is going to be 4 times n. Okay, example 6. It looks like I have 1 plus 1/2 plus 1/3 plus 1/4. It looks like I can imagine there's a 1 over 1, so 1, 2, 3, 4, 5, 6. I have how many terms? 6 terms. So I know that's going to be up here. And I know n is 1 for my first term. And I'm going to say that my rule is 1 over n. Okay, because 1 over 1, 1 over 2, 1 over 3, 1 over 4. And that is it in sigma notation. Okay, I hope this helped.